Okay, today we're doing multiplying binomials. Remember, bi meant two, nomials meant name or terms. So we're going to be multiplying two terms to two terms. And just for the record, I'm not building these with the blocks or the manipulatives. I believe you can understand this concept without building them or drawing it out. So for me, when I teach it, I don't teach to where you need to draw this or build it. So before we multiply two binomials times two binomials, like see, this is not a binomial, this is just one term. I'm going to go over just multiplying one term to two terms. So look at 25C number 1. When you see something in front of the parentheses, what does that tell you to do? It tells you to distribute. If you saw one number in front of the parentheses, you would distribute. Distribute is multiplying. These parentheses tell you you're multiplying. So we have to do x times x, and it's x times x, not x plus x. X plus x would be 2x, but when you do x times x, so over here off to the side, x times x. If I had 5 times 5, yes, that's 25, but I can rewrite it as 5 squared. 5 squared means 5 times 5. Well, the same is true. X times x, you can rewrite it as x squared. X squared means x times itself. So when you do x times x, that is x squared. Then when you do x times a positive 1, that would be positive 1x. You can't add x squares to x's. You can only add x squares to other x squares, and you can only add x's to other x's. So this is your final answer. Now, look at 25B number 2. Again, you have this 2x times x plus 3. What do you do with this thing in front? You distribute. So this is 2x times x. This is an implied 1 in front. 2x times 1x. You multiply numbers to numbers and letters to letters. So 2x times 1x, 2 times 1 is 2, and x times x is x squared. So 2x times 1x is 2x squared. Now 2x times a positive 3. Well, a positive times a positive is a positive. 2x times 3, multiply your numbers together, 6, and then you still have the letter. You can't add x squares to x's, so this is your final answer. Alright, now let's talk about multiplying binomials, which means we're going to multiply one binomial to another binomial. There are two different ways you can do it, so let's talk about the first way. Before we do this, let me just go back over long multiplication just with numbers to just jog your brain. If I said let's do 12 times 24, how did we do that? You took this number times this number. 4 times 2, you wrote it right there. Then you said this number times this number, 4 times 1, and you scooted over and wrote that number there. Then what did you do? You start with the 2. 2 times 2. And because we started with the 2, we started with this column, we write our answer right here. You scooted over 1. So if you want to put an X in that column, you want to put a 0 in that column, if you want to leave it blank, whatever. Some people put an X to say don't write in that column. I would not recommend that since we're dealing with X's now. I would not recommend writing an X. I would recommend leaving it blank or writing a 0 to remind you to scoot over. 2 times 2, 4. And it goes, this 4 goes right underneath there. And then 2 times 1, scoot over. Then what did we do here? We added. So watch your operations. Up here we're multiplying. Down here you're adding. So you added all your terms together. Okay? So that was long multiplication. So now we're going to use that same idea to now do that with algebra. Okay, let me get rid of that, get that out of our way. So, same is true. First thing we're going to do, we're multiplying. This tells us right here we're multiplying, so look at your operation symbol. So you do this times this. A positive 3, look at your sign. When you get into Algebra 1, you're going to start having negative numbers. A positive 3 times a positive 8, which is a positive 24. You need a sign there. Now you do this times this. A positive 3 times a positive x, or if you want to think of it as 1x. So positive 3 times a positive x would be 3x. You're multiplying your numbers together, 3 times 1. Now what do? We start over here. And because we start over here, we're writing our answer in this column straight underneath it. So if you need to write a 0 here plus 0, that's completely fine because we're starting here. So we're saying x or 1x times 8. 1x times 8 is a 8x, positive 8x. Now 1x, and then I need to put a positive sign, it's a positive. 1x times 1x or x times x. X times x, x squared or 1x squared. You don't have to have the one right here in front if you don't want to. So then we add everything just like before. We add now when we get to this point. 24 plus 0, positive 24. Positive 3, that's an implied positive. Positive 3 plus 8x. 3x plus 8x is positive 11x's. 3 of these plus 8 of these, 11 of these. Then there's nothing to add my x squared to, so I have that. And then I can't add x squares to x's to numbers, so this is my final answer. When you multiply two binomials together, most of the time you will end up with a trinomial. Not all the time, but most of the time you will end up with a trinomial. Alright, let's do it again on 25D5. Okay, so again, we're multiplying. Look at your operation symbol. So where do we start here? Just like long multiplication with numbers. This times this. Positive 4 times a positive 5 is a positive 20. Positive 4 times a positive 2x. Multiply your numbers together. Positive 4 times 2x, 8x. Now we go down and we scoot over. We're starting with this to say x times 5. So since we're starting with the x, it has to be written right underneath there. So 1x or x times a positive 5 is 5x. It needs to be written right underneath where I'm starting at, all lined up. And that was a positive. Now we're saying a positive x times a 2x. If you need to put a 1 in front of there, that's okay. 1x times 2x. Multiply your numbers together. 1 times 2, 2. And x times x, x squared. And that was a positive. Now what do? All of this gets added. Write your operation symbol so you visually see it. This is a 0 here, so positive 20 plus 0 is just still a positive 20. Positive 8x plus 5x, positive 13x. Nothing to add my 2x squared to, so I just bring it down. I can't add x squares to x's to numbers, so I'll leave it just like that. Okay, now we're going to do the second way of multiplying binomials together, which is this is the more common way you're going to see it in Algebra 1. You're going to do it like this more often, or really all the time in Algebra 1, and it's called FOIL. So, and then just so you know, FOIL stands for first, outside, inside, last. You will hear me say that over and over and over. F-O-I-L. FOIL. First, outside, inside, last. Why do we call it FOIL? If you look at 25D2, you have this binomial times this binomial. Two parentheses together implies multiplication. So x plus 2 times x plus 8. When we FOIL, all we really are doing is distributing when we're multiplying it out horizontally. The first way we did it, we multiplied it vertically. Now we're multiplying horizontally. When you FOIL, you take this x and you're going to multiply it to that one. Then you're going to take it and multiply it to the last one. You're distributing. You take this x and distribute it to both things in this parentheses. So let's do that first. So x times this x. 1x times 1x is 1x squared, or just x squared. Then a positive x times a positive 8 is a positive 8x. Now, what we do is we take the positive 2 and distribute it to everything. I would recommend you draw these little arcs on your paper just like I did. I've had students all the way through calculus who would draw these arcs on their paper just to remind them of the process to do it and to make sure that they didn't forget anything. So now we're going to take this positive 2 and distribute it to everything in the second parentheses. So positive 2 times x is a positive 2x. Then a positive 2 times a positive 8 is a positive 16, because a positive times a positive. Okay, now you look, do you have any like terms to combine? Yes, you can combine x's to x's. So that would be 1x squared, or just x squared, positive 8 plus 2, I have 8, I have 2x, so that would be a positive 10x plus 16. I can't add x squares to x's or to numbers. That's like apples, bananas, oranges. Only add apples to apples, bananas to bananas, and oranges to oranges. Why do we call this FOIL? Here, I'm going to erase this and go through this to show you why we called it FOIL. We took this, we multiplied the first things in the parentheses together. Then we distributed to there. These are the outside things of the parentheses, the most outside terms of each parenthesis. Then we took the 2 and distributed to there. These are the 2 insides, the most inside things of each parentheses. Then we took it and distributed to there, which these 2 things are the last things in each parentheses. So we did the first, outside, inside, last. That's where the word FOIL comes from. Okay, we're on 25F3. We have a binomial times another binomial. You can only FOIL when it's a binomial times a binomial. Okay, how do we FOIL? We take this first thing and distribute it to both things in the second parentheses. So let's do that. So 2x times, and this just says x, but that's an implied 1 in front of there. So 2x times 1x, you multiply your numbers to numbers and letters to letters. So 2 times 1 is 2, and x times x, x squared. Now take your 2x and distribute it to the positive 1. So 2x times a positive 1, positive 2x. Multiply your numbers together, then carry that letter along with you. Now we need to take this positive 3 and distribute it to everything in the second parentheses. So it's a positive 3 times a positive 1x. So that would be a positive 3x. Now positive 3 times a positive 1, which would be a positive 3. Okay, now you look to see, do you have any like terms you can combine together? Yes, you can combine your x's together. You can only combine x's to x's, x squares, and numbers to numbers. So 2x squared, positive 2x plus a 3x. You have 2x, you have 3x, you have 5x plus 3. You can't add x squares to x's to numbers. You can only add x squares to x squares, x's to x's, and numbers to numbers. Okay, we're looking at 25C, number 13. I'm going to read the whole thing, then go back through it. Christopher added 8 to a number, then he added 5 to the same number. Next, Christopher multiplied the 2 resulting numbers together. Express his final answer as a polynomial. Remember, let your brain explode, then take a deep breath. Now let's just go back through it. Okay, we're dealing with a number, so you need to decide what letter do you want to represent your number. I'm going to use N for number. So the very first sentence says, Christopher added 8 to a number. Okay, so if I'm going to take a number, N, and then I'm going to add 8 to it. Okay, it said then he added 5 to the same number. Okay, so the same number, which is N, and now I'm going to add 5 to it. So I have those 2 binomials. Here it says next, Christopher multiplied those 2 resulting numbers. So what I need to do is take these 2 things and multiply them together. Okay, so I'm just going to rewrite it here a little neater, closer together. So I'm multiplying those 2 binomials. So once you get it written out like that, then you just say, oh, okay, I FOIL. So I take this, distribute it to both things. The first, then the outside. Okay, so N times N. N times N, N squared. Because N squared means N times N. N times a positive 5, positive 5N. Write your number first, then your letter. Then take this and distribute it to both things. So that would be a positive 8 times N, which would be a positive 8N. Then a positive 8 times a positive 5, positive 40. These are your like terms that you can combine together. N squared plus positive 5, positive 8, you're adding positive 13. I have 5, I have 8, so positive 13n plus 40. You can't add n squares to n's to numbers, so you leave it like that. That is your polynomial. Polynomial just means many terms. Turns out that's actually a trinomial, 1, 2, 3 terms, but it still can be called a polynomial. Now look at number 14. Number 14 says, if the value of Christopher's number is 3, what is the value of the polynomial given as the answer in number 13? Then it goes on to say, if Christopher's number is changed to 6, what is the new value of the polynomial? Okay, let's just start back with the first question. If the value of his number is 3, they're saying, okay, well, what if n equals 3? That's what they're saying. What if the value of his number is 3? What is the value of the polynomial? So what they're asking for, here is my polynomial, n squared plus 13n plus 40. Well, they're saying, what if n equals 3? What if the value of his number is 3? All we need to do is take our 3, plug it in here for n, like what we do when we check, and then figure out what does that equal. So everywhere we see an n, we're putting in 3. So here, 3 squared plus 13, remember 13n means 13 times n, times 3 plus 40. Now we follow PEMDAS. PEMDAS says do exponents first. 3 squared, don't tell me it's 6. 3 times 3, 9, plus 13 times 3, that would be 39, plus 40. PEMDAS says do exponents first, then do multiplication and division. That's why I did that next. I did my exponents, now I can do my multiplication and division. Now I add, and PEMDAS says you need to add from left to right. So when we add all that together, I'm using my calculator just to make sure I don't get anything wrong, that would be 88. So if the value of his number is 3, then that whole polynomial would come out to 88. Okay, the second question says, if Christopher's number is changed to 6. In other words, now what if his new number is 6? The value of his number is 6. What is the new value of the polynomial? Same thing. Take your original polynomial, n squared plus 13n plus 40. If the value of n is 6, take 6, put it in everywhere you see an n. So therefore, that would be 6 squared plus 13 times 6 plus 40. PEMDAS says do exponents first. 6 squared, 36. PEMDAS then says do multiplication and division next. So 13 times 6, 78. Remember, I'm okay if you use your calculator. Now we add everything left to right, and that comes out to 154. So if his new number was 6, the value of that polynomial would be 154. Okay, now look at 25C15. The length of a rectangle is f plus 10 feet, and the height is f plus 5 feet. Express the area of the rectangle as a polynomial. We want the area. If you can draw a picture, I always recommend drawing a picture. As humans, we are visual people, and having a picture does help. The length of my rectangle is f plus 10, and that's feet. I'm just going to put down here feet, just to remind me. Then the height is f plus 5 feet. I want the area. How do I find the area of a rectangle? Area of a rectangle is base times height. Well, what is my base? My base is f plus 10. That's this right here. What is my height? F plus 5. It's base times height. So I'm taking these two binomials and multiplying them together. How do I multiply binomials? FOIL. All I do is take this first thing and distribute it to the second parentheses. So f times f would be f squared. F times a positive 5, positive 5f. Now let's take our 10 and distribute it to both things in the second parentheses. Positive 10 times f, positive 10f, positive 10 times positive 5, positive 50. Now we combine like terms. So f squared, positive 5 plus 10. I have 5 and I have 10 plus 15. You're adding at that point, plus 50. That's my area, and then area is always in square units, so that would be feet squared. Since they mentioned units, you need to mention units. So it says to express the area as a polynomial, and so that would be your area as a polynomial.